see it now? So let me start with DevOps. So in the initial days, not initial date, even still, uh, how you there would be some developers working on a project. I'm talking about a software project. So first of all, how do you develop a software? First, one of the customer would come to you and they will tell you, I need to develop a product. For example, I want to develop a Ola cab or Uber cab like application, and I want to start a business. And they would be coming to your company asking you to set up a software for him, right? So in such cases, there are few steps that you follow. You first gather all the requirements that he need. I mean, what he is expecting out of his software. Then you basically would write the codes and make his project ready. Consider you are developing a web application, something like www.example.com. You are developing a web application and you ask him what are requirement that he expect. For example, customer would want you to create a web application using which his user can book a cab, or the driver can log into the web application and confirm the bookings. Then they can get the phone number of the driver and driver can get the phone number of the customer. So he need an application which support all these features, right? Then you, once you get the requirement, you would pass along, you will do some design and you will code it, and finally you have the working software ready, right? So probably typically in software firms there would be a team of developers. This is the developer team who would be writing the codes, and there would be a system administration team. So basically, once your website is developed, the responsibility of the development team is only writing the code. So they write the code, they set up everything, they test it, and the code is working. Your web application is now ready. And in order to internet users to access this web application on www.example.com, this code which developers created should be deployed on some infrastructure. Basically, you may have few servers, and to this server this code should be copied to, and your server should have enough software running in it to run this application. Maybe or 4 or 5 server you have, they run together and all of them has this necessary code they need to run, and then only the internet users can access the website www.example.com once it move into the server. And there would be a system administration team, sysadmins, right? And their roles would be most likely they would get the code from the developers and they will copy the code into the infrastructure, and they would have some additional responsibility like installing software on your server that help deploying this code, everything. So this was how previously the practices were followed, and this is a as the time progressed, this tend to be a very bad idea, because let's say developer done with their coding, then they ask the sysadmin that I am done with my coding, please copy my code into the necessary servers and make the website accessible to the internet users. And at that time system administrator get the code and then they manually copy all these code into each of the machines. Then they restarted the software, whatever software they need to install, they installed it. Then they set it up everything, and it is probably a time consuming process, and it is also possible that the system administrator would be busy at that point of time, and maybe they are on leave or not available. Then the deployment process would be stuck. The developer does not know how they can put the code into the production. So there is a proper disconnect between the developers and a system admin. So once the system admin become available, they would basically copy the code into the infrastructure and make the application up, and this is actually a waste of time and money as well. So the root problem with this structure is there is a proper disconnect between the developers and the system administrator, and it is a serious problem actually. If the system administrator are not available, the developer cannot do anything. They don't know how they can move their code into the production infrastructure or anything. So in DevOps, you what you basically do is this developer role is still exists, and the system admins, instead of doing all this manual copying of the code and then restart of the software, sysadmin would be now more oriented into setting up some DevOps tools. Basically, whenever you want to put your code is ready, and normally in recent days, all the developers save the code in a common repository. So there would be a common repository. It is nothing but a centralized storage where all the developers are saving their code into, right? And system admins have this code, and copying the code into your infrastructure can go through a series of steps. You may need to copy the code, and there can be, it is in ideally it is not just the 4 server that you may have in your infrastructure. It can be 40, 400, or even thousands of server can be there inside your infrastructure. So when you have such large number of server in your infrastructure, copying the code to respective server and restarting the machine, it's going to be a really headache. There are lots of procedure that you do during a deployment. You have to get the code from a repository, then you have to compile this code, you have to build this code into some server understandable form. Then there would be a list of codes, right? Not just this could be one cab application, web application, this is an Android application, this is an iPhone application. All this thing needs to be go into your infrastructure, and you don't know this web application should maybe going to some 40 machines, then Android application may be going into some 100 machines, then iPhone application would go into some 80 machines, and it's a very large infrastructure which cannot be humanly managed, right? So for that, what you will now do at the time of deployment, you get the code from the repository automatically, you use some tools to build compile and build it, and once your code is ready, you automatically send the code into the respective machines using some tools without human intervention. And once the code everything is deployed onto your infrastructure, you will run some automated testing. Basically, you run some test, you try to book a test cab, or you try to contact the driver through his phone number. You do some basic testing on the application and make sure that the deployment which you just did went successful, and it does support all the new features which you just added. So you want to run some tests for that. Then you also want to send out an email to everyone telling them about the deployment status. This software, this new version of code has been released to my infrastructure and it was successful, or it failed at this point. So whatever the outcome is, you want your respective people get notified through email. So you want to send out emails, and all these process are done in an automated way using DevOps tools. So what happens if a system administrator is not available? Nothing, because Once your entire process, including infrastructure, is automated, you do not need to have your system administrator called each time. You can actually simply run it yourself, right? So this is the main, the basic underline, uh, underline or the context of DevOps. What all things comes under DevOps, and it is not complete yet, uh, which I will discuss in a bit. So first I will talk about few tools that we are going to learn, and then we will come back to this DevOps concept. So for the sake of our course, first it would be some Linux basics training. You would basically create one server. I will show you how you will do it in the next class, and I believe Vinay and Vasavi, two people already did that, and I will guide you how you can do it. And in the next class we all will concentrate on doing that. uh, you will create a your own Linux machine, and it is on that machine you would be running all the experiments. Whatever I am showing you in the class, you would be doing it yourself on that machine, and you would be doing more things. I would be giving out some assignment after each classes, and that also something you have to go through. And after the Linux basics training, we would move on to some scripting. We would learn bash scripting and Python programming, right? So these are few things which a DevOps engineer would need. Sometimes, like I said, DevOps engineer does a lot of automation, right? When they want to do a deployment, they want to automate it. Then when they want to set up a new server, or set up all the machine at one shot, all the server at one shot, everything that they do, they tend it towards automating it, so that no human intervention is required. But sometimes it is possible that the DevOps tool that you use may not be capable of doing it all at one shot, and at times you may need to write some small scripts yourself. So that's why we included this shell scripting and Python programming within our context, and this would be useful for you, right? You are not expected to run any full framework or full application. It is not expected, but sometimes you may want to write some small scripts, and you will get enough training that make you comfortable doing these small scripts. And then we will move on to SCM. We would be learning Git, not SVN. Git is a revision control mechanism. Basically, like I said, in recent days, the code, the website code, or whatever code that you are developing, it is saved in a common storage, a centralized place. It is called a repository, and it is inside this repository everyone save their codes. Let's say there are 10 developers working. Here it is Tom, there is Jerry, and there is, right, there is Bob. There can be n number of developers working on the same project, but whenever they, let's say Tom made some changes, made his code changes, he would commit those changes to the common repository. Now let's say whenever Jerry want to make some code changes, first thing Jerry does is he will get the code back from the repository. He will basically save the code, and then he work on his changes, and once he made his code changes, he will commit the changes back to the repository. Similarly, Bob also does the same thing. So basically, uh, this common repository makes the developer work individually. They don't need to dependent on others. Let's say Tom is working on it, working on some code changes. That does not stop Jerry to do his own code changes. They can work together at the same time on their own changes. So developers can work independently, and whenever you want to put this code which you had developed into your infrastructure, that means your internet server need to be set up with the latest code changes, then you use the same git repository to copy the code into your production servers. To the servers you will deploy your code by using some automated mechanism, which we will come to that in later. So the repository is a good practice that is followed by all organizations today. All the code is saved, and one big advantage with this, now the developers don't need to worry about the backup. They have backup in each developer's machine as well as in the repository. Just in case any of the machine crashes, they can get the code back from any of the users machine or the central repository machines, right? So backup is one purpose, and there are lots of advantages that Git offer. Git is a repository that we would be learning in the class. I would be showing you how developers can work individually and how they can commit the changes to the repository and do a checkout from the repository, and how this Git repository URL can be used for doing the deployment. How you can do the deployment from Git. So those kind of steps is what you would be doing a lot as a DevOps engineer, and I will show you how you do that in the real work time environment, right? And after Git, we will move on to some build management tools. This is some we would be learning Ant, not Maven. Ant is one tool. Let's say if you are a Java developer, probably you may have heard about Ant. When you develop a Java code, this Java code cannot be directly copied to your server machine. It will not work. Even if you simply copy the Java code into your server machine, it would not be accessible for the internet users, because the plain Java code cannot be understandable by your server. You have to convert this code into the machine understandable form. For that, you first need to compile your code, and once you compile it, you have to build your code and create some war files, and after that this war file should be copied to your server machines. Now it will be accessible for the internet users. They can access www.example.com on their browser, and they will see the latest code changes. But you should first do these many things, and it is not advisable that what a developer is supposed to do. Can anyone tell me what is the role of a developer? What they are supposed to do in their daily jobs? Only coding. They are not supposed to do anything else. They just need to concentrate only on coding. They don't need to concentrate on compiling their code and then building their code, then creating the war files and doing the deployment. All those things should be automated. If they are automated, then developers can concentrate only on coding, right? And Ant is one tool that will automate these jobs. We will take a Java project. We will basically download a Java project, a source code from internet. Then we will use Ant to compile it and build it, and then deploy it to a application server, right? And Tomcat, we would be also learning both Apache and Tomcat. Tomcat is an application server that can process Java application. For example, let's say you coded and you built your Java code, and your Java code is ready to be copied to your production machine. This is a server, and you copied your Java code, you deployed it to a application server, and this is the application server. It is running a software called Tomcat, and Tomcat itself is an application server, and it can process the Java code. So It's actually whenever somebody access www.example.com and they are browsing a Java website, it's actually the Tomcat server that process the Java code and serve you the website content, and it would be displayed on your browser, right? So Tomcat is an application server that serves the Java dynamic page to the internet users, right? Similarly, there is another web server that you would learn along. It is Apache. Basically, it is a web server that is intended for serving the static contents. By the static content, I meant to say the images, some style sheets, or some photos. Those kind of things are static images, and whenever a browser hit www.example.com, it would hit Apache, and in Apache you tell them these are the images or the static files that needs to be served, and Apache will serve those files to the browser. So basically these are some this is a web server and this is an application server. We will be learning that in detail. I'm not going into much detail which would simply confuse you. I don't want that. Just wanted to let you know what these Apache and Tomcat are. Apache is a web server mainly intended for serving static contents, and Tomcat is a application server that serves the Java dynamic pages, right? And I hope everyone know what is a database. Database is simply a storage where you save data, all right? And there are different models in saving data into a database. uh, MySQL is a example database engine, and MongoDB is another one, but both MySQL and MongoDB are conceptually very different. So we would be learning both database technologies in detail in the class. You need some level of knowledge on the database as well, and database is definitely not a DevOps tool that we are learning. But there are many of you who does not have any background onto the database technology, so it's good that you know these things, right? So we would definitely learn these things in detail, and at this point we actually move on to DevOps tools, right? So initially there would be a cloud computing class, AWS. Maybe I should put it as a different subject altogether, right? So after the database technologies, we will move on to some cloud computing. So actually the DevOps is incomplete without cloud computing. So basically we would concentrate on AWS. AWS is a major cloud hosting provider. I don't know whether you heard about what is web hosting. By the term web hosting, what it means is there is a data center. This is the data center. It is basically a building which the hosting provider manages, and there would be physical machines located on this in the data center. Each of the machine will have an IP address. So whenever you want to buy a machine, what you do is you go with some provider. For example, GoDaddy. There are many server providers who sell server machines. So you can sign up with one of those providers and buy a server, and it can take for traditional mechanism. If they are following the traditional mechanism, what the data center guys does is once they got an order, in the order I told them I need a Linux machine which has a 4 core CPU and 10 GB of RAM, then 100 GB of hard disk. So I ordered a server with those specifications. Then data center will buy the machines and put those machine into their data center. then they will install Linux, then finally they will give all the credential to me. And it can take, depending on how much the order processing takes or the server they got, it can take 2 days to up to 1 week as well. So I have to wait till that time to get the machine ready. This is not a desired way, and this is how the traditional server providers used to work in early days, right? And now things are changing in the sense this cloud computing came into picture. And what the providers now, typical providers, what they does is they still have the data center, but in a virtualized way. Whenever I want to order a server, this is me, I want to log into www dot aws.amazon.com. It is a cloud hosting provider. I logged into their portal, and where I can see a lot of buttons. I can see a button called create a server. I see another button, create your own network. I see another button called create your database, create your repository. I see a lot of option where I just need to click and my server is ready. Within 1 minute, I will get the server. And I do not care what AWS, what technology AWS uses to serve me this machine. All I need to care is just log into their portal, click on create server button, and my server is ready within 1 minute. I can log into the server and then I can start working on it. So this is what this cloud computing brought us here, brought us at this point. Whether you want to create your own network, whether you want to create your own server, whatever you want to create, it is simply a few clicks of a button and you are done. So it's that is not just about cloud computing. We would be learning cloud computing in detail, and AWS is the leading cloud hosting provider today. Probably it is being used by almost all startup companies. I mean, maybe I don't know any count, but whichever company I know about, they all have their infrastructure in AWS. At least 70% of them have. So, and that opens a lot of job opportunity for the engineers who know AWS, and for any DevOps roles that you joins into, would 90% of the chances is that they are on AWS. So AWS is an essential to, in the context of this course. So we would be learning AWS in detail, what all the services they are offering, how you can create a server, how you can create your own network, how you should architect your infrastructure in AWS, how your network should be configured. All those things we would learn in detail, right? And after the AWS classes, we will move on to the DevOps tools. These are some important DevOps tools that we would be learning in detail, not cloud formation. This is an AWS service. I'm not covering that. And continuous integration. This is also something, I will talk about in a bit, right? What is continuous integration and what is this agile model? So, in earlier days, there was something called waterfall method. Whenever you want to develop and architect a software, there were certain steps that you need to follow, right? You first need to get all the requirement from the customer, or it may not be the customer, it may be your own company that is building this application. So you have to get the requirements from concerned people. Then once you got the requirement would be, I want a CRM application, or I want a cab application, whatever. I have to gather all the requirements that the software will need to have, all the features that software should support. I gathered all the requirements, then I will plan it. I make some planning. How many people would need to create this software, and how long it is going to take, how much money it is going to cost to us, and if you have to give the bill to a client, how much you should give an estimate. All those kind of planning would be done. And once you are done with the planning, you would have allocated the team now, and you will start designing the software. And after designing the software, you would basically implement it or code it. You will write the codes and implement the software. Then finally you will do some testing. Your software is ready. You just want to run some test and make sure that your software is working fine. So conceptually there are 5 stages. What is the initial stage? Initial stage is requirement gathering, right? Requirement gathering. After that there is planning. After that there is design. And you are not worried about these things, right? These are most likely be done by a manager, this planning, and not by the manager, it is done by the entire team. But the DevOps engineer role would not comes much into this, but I wanted to tell you how this continuous integration has evolved, right? So requirement gathering, then you do the planning, then you do the designing, then you do the implementation. The developer will do the coding at this point, and there would be a testing team who will test the software. So in any of this you do not see any DevOps role, right? But we will come to that. The DevOps role is embedded with all these. So at the end of the testing, your software is ready and it can be released to public. And by the time released to public, what do I mean? The code can go into your infrastructure that contains a number of server machines, and into these server machines you will deploy your code. Then internet users can start using this, and it is very less likely that you would directly put your code into a production infrastructure. You may have some testing environment which will contain few server, and you would be first deploying your code into this testing environment for testing. And once the testing is successful, you will put the code into the deployment production environment, whatever. Let's leave that part. So here you do the release. By the release, what you mean is you put the code or whatever changes you need to put, you put them into a production infrastructure. Okay, and this method has some disadvantage. This method was used by all the companies previously, and the method is called waterfall. What is waterfall method? It is a software architecture method using which you design, you implement a software, you create a software. It explain about all the stages that are involved. And there are some disadvantages with this waterfall method. What are the disadvantages? The software is designed at one shot. Any software that is designed at one shot is going to be very complex, because you are taking care a lot of things at same shot, which can cause problem in designing, problem in implementation. You may not have followed the right strategy for these things, so it is a real headache. And you also need a very proper documentation. Since your software is already trained to be a complex, you need a very good documentation so that anyone who joins your team can understand the software. And whenever, let's say, the customer, in the real time, the customer requirement keeps on changing. In 99.9% of the cases, customer requirement will never be the same. When you develop the software, customer had given you some requirement sets, but in future he will come to you and definitely ask you for some feature enhancement. For example, let's say this it's a Ola cab. You are developing an Ola cab application, and you did not consider the fact that there would be a lot of people who want to track the cab. And initially when you developed the software, you did not think about that, and at later points the customer found that all the competitors also offer a mechanism so that a third person can monitor your cab, where you are going to. You can basically track it for some security purpose, which your software does not have. Then customer will come to you and tell them, please add this feature also to my software. And since we did not consider the fact of requirement changes, it would be tough to implement this, because your software is already a bit complex and you don't know how which part you need to modify and how complexity that would involve. And if you implement this, what is going to be changed and what is going to be broken, all those facts needs to be considered, and it is going to be a really headache. So requirement changes is not supported in waterfall method. Not supported in the sense, not supported in a straightforward way. It can be done anyway, but it's very difficult. And other thing is, customer keeps on spending money throughout these stages. It can take up to how much time? Based on the complexity of the software, it can take up to 6 months or 1 year or maybe 2 to 3 years. Till that time, customer keeps on spending the money, and he can run out of the money as well, because there is no income that he is generating out of this software. Only thing he does is he is just keeping on paying you, and at any point customer can really think about dropping this project. So that is very unlikely, and you do not want that. And also you need a pretty big documentation to explain your software. That is also a disadvantage, considered to be a disadvantage with this waterfall method. And then people started thinking about an alternative, and then they came across uh, some solution called agile. What is the term agile means? Agility. How you heard about the English term agility? The term agility means is it is open to change. It's flexible to change. So in the agile model, what you would do is you gather all the requirement in the initial stage, same steps, the stages that are exactly same. There is requirement gathering, planning, design, implementation, and testing. But in the initial stage, you would not develop the entire software. You would just try to find out what is the core application. For example, if you are developing a cab application, you will first think about developing a web application with minimal features. What is the core feature for a cab application? User should be able to book a cab, and the SMS should be sent to the driver, and driver will get the phone number of the passenger who booked the cab. Then driver can call them and they can communicate each other. That is good enough in the initial stage, right? Why did I do that? I can simply put my software, release my software as soon as possible, maybe within 1 week. It is a very small task I need to do. I can within 1 week I can deliver this software. Only feature I am looking for is, customer can book a cab, the SMS phone number would be sent to the driver will then call and they will travel. It's a very simple application and it need only 1 week. So I did the requirement gathering, I go through all the stages, I did the planning only for the core component, I did how designing. And designing would be very easy because it is a very small component that you are developing at this point, and the implementation is also very fast. Testing is also pretty straightforward. And at the end of the stage, within 1 week, your software is ready to be released, and your software support booking a cab from the web application, right? Customer started generating revenue within 1 week, right? He did not spend much because it's just the 1 week of developer's time that he need to pay, and at the same time he started generating revenue. Then at this point your software is ready, but it has only one feature, and in the next time you decided, okay, now passenger can register on the website and create their own logins, right? You thought of implementing the second feature, and in the second implementation you think about user login and you implement that feature. Any passenger who want to book a cab, they first need to register with the application and they need to log in. So the user login is now being worked on in the second iteration. It again goes through all these stages: requirement gathering, planning, design, implementation, and testing. And at later you decided that now I need an Android application so that customers can book from their mobile. I again repeated these steps, and at this step I would deploy the Android application. So within every week, let's say I'm able to put more features every week, my software would incrementally become large, right? Let's say first web application, then login feature, then Android application, then some driver tracking feature, then some iPhone application, and my software is actually growing eventually, and at some point it will become a fully capable big software. So you do a lot of iterations one by one, right? To and your software would eventually grow. And what is the advantages? Customer will start generating revenue very quickly. Then other advantage is that you do not need a very big documentation, because whenever you do a release, right? Whenever you do a release, you prepare some release document, and on the release document you simply write down what is being under construction and what is being released and what is the plan for next release. You make write it down on a release document. And this release document, if I tell you, these release documents actually, if you read from top to bottom, it explains your software's growth, right? I mean, the one who reads it can easily understand what your software is. You can read it like, okay, initially somebody is reading the release notes from January 1st. On January 1st the application is released, we supported only web application. Then on January 7th this customer login is created, and these were the code changes made, and these were the features added, and these were the design, and this is how it is designed at that stage. So using simple release notes, you can, it explains your entire architecture. So you do not need a documentation for this agile model. Whatever you have in the release document is going to suffice. And also it is open to feature. I mean, whenever you want to add up a new feature, you just add up a new iteration, then again do all these stages. So since for each iteration you are following these stages, it wouldn't be very a tough job to add a new feature. For the new feature also you can have a very good strategy using all these 5 stages. So I was just giving you this, the most common agile. What is agile? And we are not still not much interested in this software development process. What we are interested is in the software release. Here you can see your software is being released every week, right? And it is not as simple as it looks like in the picture. Whenever you want to do a release, it's a tough task. There are a lot of things that you need to take care. For example, first thing would be all the modern softwares would not be residing in a single server. There would be a number of server your application would be residing. There may be some web server, application server, database server, like that. There can be hundreds of server in your infrastructure. So whenever you are making a release, after testing stage, you do a release. Whenever you do a release, you are making changes to your infrastructure, and thus that change is actually a huge change. And there are certain things you need to take care. For example, your software is already being used by the internet users. Just because you are making some release does not mean that you should interrupt any of those users. Your software should be working for the existing users. Then this release should not cause any downtime for these existing users. Then also it should not break any existing features. Let's say sometimes it is possible that you are adding up some feature and it can break some design, it can break some of the features. That should be taken care. There are a lot of things you need to take care before you actually go with this. So for that, a team has evolved, and they are called release engineers, right? These are not system administrators, but they are some release engineers who will take care of these things. Developers does not need to worry about how to deploy it without any downtime, or how they can copy the code to infrastructure. Those things are completely taken care of by release engineer. And sometimes they are also referred as DevOps engineers, right? And this is not the exact definition of DevOps engineers. Then the role of DevOps engineers can vary from release management to configuration management to repository management to a lot of levels that we will come to. And release is one job that is being taken care by the DevOps engineer. What they do, they will use some tools and make sure that your release process is as much as automated as possible, and it does not make any downtime to the existing user or whatever concern I just spoke about. DevOps engineer work towards fixing those limitations, right, by automating things. So it is actually these tools that we would be demonstrating in the class, and we will see how you can, this Jenkins is one tool that you would use during the deployment, and even Docker and Chef also can be used along with the deployment. We will see how you can use these tools. And Chef is altogether, it's a different tool. It is basically used for configuration management, not for deployment. It can be used for deployment also, but it is called a configuration management tool. So I would write down Chef as a separate topic. That would be better. Configuration management using Chef. And Chef is also one important topic that we would be learning. Basically, let's say you have a large infrastructure which contains too many server, and let's say you have 500 server, let's say 50 web server, 100 database servers, and some 10 load balancers. There are many different types of server that you have in your infrastructure. Do you think, is it humanly possible to remember which surveys do what role, and what they should get, what software they should be set up with, what websites they should be running? It is not humanly possible to remember all these things. So we do not let human do any of these things, we let the tools does, right? There is something called configuration management, right? This configuration management tools will continuously monitor your infrastructure, and it knows how your infrastructure should look like, which are your web server machines, which are your database server machines, which are your caching server, or which are your load balancers. These tools already know all these things. It also knows what all software should be installed on your web server, and how many websites should be running in your web service, what are the Apache or Tomcat, whatever needs to be installed. All those things also this configuration management tool knows. It also know what your DB databases should contain, how many database you need, what is the database engine it should be running. That also it knows everything. What your infrastructure should look like, the configuration management knows, and it will manage it. Basically, if you want Apache to be installed on these machines, it will configuration management tools will install it and automate it. You don't need any, you don't have to log into any machines, then type the command install Apache, install Tomcat. So those manual steps are completely avoided, and it is completely your infrastructure would be managed using a configuration management tool. We will see, we will learn Chef in detail. Chef is one type of tools that does this, and we would learn that too in detail in the class. So then some binary repository manager nexus and some infrastructure, continuous infrastructure monitoring, how you can monitor your infrastructure using some proactive monitoring tools. Then how do you review your code using Sonar? These things would be also covered under this course. And for AWS and Chef, there would be detailed lab that would show you, how you can use them in your infrastructure. So you will get a clear picture, a real work environment picture after this course. And those who are looking out for job, or those who want to put up these features into your own infrastructure, please attend this lab session manually, especially for those who look out for job. You should be able to explain what you worked on, right? What tools you had used, and what you were working on. So basically it would be a work oriented course that we would be going through. I mean, that's the plan. And you will also have assignments, and also each sessions would be recorded and shared to you in Google Drive. And each sessions, there would be assignments after each session, so you really need to spend extra 1 or 2 hours working on those assignments or reviewing the course contents, course videos. So yeah, I would be giving you the proper guidelines how you should go about learning these in detail, all the stuff. But try to attend all the classes and go in a regular basis, because since we are learning a lot of tools, if you want to go in sync, please attend all the classes, and then make yourself up to date with the whatever you learned for that day, right? Then follow the same strategy until we finish the course, and after the course I would be giving you some real-time work assignments. Then for the next 1 or 2 weeks you work on them. That will make you completely confident about this DevOps, right? And if you look at the industry, if I talk about the industry demands for DevOps engineer, it's huge. Basically, there are lots of startups and lots of established companies, and there are a lot of open position for DevOps engineer, but the capable people in the industry, in the world, is very less compared to the requirement that is there in the DevOps field. So, and it is, they are all highly paid jobs. Normally this DevOps opening would be in either startups or some production companies, and they never bother about any kind of salary negotiation. If you're looking for a highly paid job, DevOps is the right solution as of today, which you can learn easily, and not very easy, I wouldn't say it is too easy, but it is something you can, with time and effort, you can learn it. And if you're looking for a job change, this is something, a right field you all can go to. And even if I give you some numbers, there are people with 3 years of experience got jobs with a scale of 12 to 13 lakhs, up to 12 to 13 lakhs in some companies, in startups, not in big established companies. Within startup also pays you very well for the DevOps roles. So that's pretty much about the industry experience. Shashidhar is asking about Ansible. We are not covering Ansible. Chef is a similar tool. So Chef is what we would be covering for the sake of this course. It is more or less, does the same function as Ansible does. So it would be Chef we would be learning in detail in the course. And I would give you an overview about Puppet and Ansible as well, and how they differ from Chef. But you do not really need to learn more than one configuration management tool. Chef would suffice, right? And that's pretty much So do you have any questions? Anyone? Please go ahead.
Hi. Actually, are you covering the puppet? No, right?
No, we are covering only Chef, and Puppet and Ansible are also similar tools. Chef,
Okay.
Puppet, Ansible. They are all configuration management tools.
Okay.
So
Okay. Okay.
basically, I mean, if I cover Chef, then Puppet and Ansible would become duplicates. I don't want.
Okay. And I wanted to know, like, you're teaching all this tool. Like, what about the installation? You'll teach us install in our local machine to practice as well.
Basically, you all need to sign up for AWS. I will show you that tomorrow. You all need to sign up for an AWS account in cloud,
Okay.
and from there you
Mm-hmm.
have to buy a machine, and you don't have to buy it for first 1 year. You can use one Linux machine for free throughout the year.
Okay.
So you would need this. And Shashidhar is asking, we need any